Today, we are diving into a really fascinating shift happening right now in software development. It's this move away from what people are calling vibe coding with AI to something much more structured, more powerful. It's a whole new way of thinking. So let's jump right in.
I mean, think about it. What if you could build an entire functioning application just by describing it, like in plain English? That was the dream, right? It felt like we were stepping into the realm of science fiction.
And for a while there, it seemed like the answer was, you totally can. This new idea popped up, and it got the perfect name, vibe coding. You just give the AI the vibe, the general idea, and it handles all the messy syntax. It honestly felt like it was going to change everything. So let's start there, at the beginning, this first phase, this sort of honeymoon period, the dawn of vibe coding. There was this incredible excitement in the air, this feeling that the old rules just didn't apply anymore. So what exactly is vibe coding? Well, it's pretty much what it sounds like. It's when you stop writing every single line of code by hand, and instead, you just prompt an AI tool. You describe what you want in plain English, and you let the machine do the heavy lifting. It's less about syntax and more about a conversation. And this was the killer feature, right? This was the promise that got everyone hooked. You no longer have to fight with semicolons or remember some obscure function name. Your job shifts. You become the visionary, the architect of the idea, and you leave all those tedious details to your new AI partner. And the benefits were just so obvious, so immediate. You could spin up a functional prototype in an afternoon, not a few weeks. Suddenly, people who weren't hardcore programmers could start building things. It let developers focus on the big picture, the why of what they were building. And for anyone working in Agile, this was a dream come true. Fast, iterative development just got a massive speed boost.
But, and you knew there was a but coming, right? As more and more teams started doing this, something strange happened. A kind of paradox emerged. That initial explosion of speed didn't always translate into long-term progress. In fact, sometimes it created a whole new class of headaches.
Which leads us to the million-dollar question. What's the catch? There has to be a catch. What was the hidden price tag on all this magical instant code? And here it is. This is the other side of the coin. That unprecedented speed, it often led to an unprecedented amount of technical debt. That feeling of higher productivity, it could quickly turn into a maintenance nightmare down the road. And all that creative freedom sometimes resulted in code that was like a house of cards. It looked great, but the second you put it under any real-world pressure, the whole thing could just fall apart.
I love this quote because it just hits the nail on the head. AI is an incredible force multiplier, but it multiplies everything, including the bad stuff. Without guardrails, you're not just building features faster, you're automating the creation of future problems at a scale we've never seen before.
And these weren't just abstract fears. Teams in the real world started running into these problems. The AI-generated code would be missing basic error handling, or it would be riddled with subtle security flaws. And trying to debug it was a nightmare because no human actually understood the original logic. For the really complex, mission-critical systems that businesses depend on, this approach just wasn't going to cut it. So it became pretty clear, pretty fast, that we needed a new way forward. We needed to keep the power of the AI, but wrap it in some of that good old-fashioned engineering discipline. And that's what led to the next evolution in this story. Say hello to spec-driven development. The idea here is simple but powerful. Instead of giving the AI a vague vibe, you give it a detailed, structured specification. A human-written document becomes the blueprint, the single source of truth that guides the AI agent. And this is the core principle. In this model, the spec is everything. If there's ever a question about how something should work, you don't look at the AI-generated code, you look at the human-written spec. That is the ultimate authority. You know, this really requires a huge mental shift. The old mindset was that the AI is some kind of magic genie that can read your mind. The new mindset, the AI is like a really smart, really eager junior developer. It's incredibly fast, but it's also very literal. You wouldn't just tell a junior dev, hey, build me a social network, and then walk away. You'd give them clear requirements, you'd review their work, you'd test everything. It's the exact same discipline here. Okay, so this all sounds great in theory, but what does it actually look like in the real world? How do you put specs into practice? Let's take a look. So we're already seeing frameworks pop up to help with this, like GitHub's Spec Kit. And it lays out a pretty common sense 4-step process. You start by specifying the what and the why. What are we building and for whom? Then you plan the how, the technical architecture. The AI then helps break that plan into small, bite-sized tasks. And finally, the AI implements those tasks. But, and this is key, a human developer is reviewing and guiding it every step of the way. It's a true partnership. Now, this structured process has led to a really mind-bending new idea. What if the spec file itself, written in something as simple as Markdown, could actually be treated like source code, a high-level programming language for telling the AI what to do? Okay, check this out, because this is where it gets really cool. On the left, you see a simple spec file written in Markdown. It's just plain English, outlining the logic for fetching some data. And on the right, the AI has taken that spec and translated it into complex, production-quality Go code. The developer is essentially programming in Markdown, and the AI is acting like the world's most advanced compiler. It's wild. So why is this so much more effective? Well, it plays to the AI's actual strengths. Large language models are amazing at pattern completion. They're not so great at mind reading. A detailed spec gives the AI a clear, unambiguous pattern to follow. The spec itself becomes this living, executable document, and you can build your security and architectural rules right into it from the very beginning.
So let's zoom out. What does all this mean for the future of software engineering? We're talking about a pretty profound shift in what a developer's job even is. I think this sums it up perfectly. We are moving from a world where the lines of code were the absolute source of truth to a new world where the human intent, captured in that spec, is the source of truth. The code we see is just the compiled output of that intent. And let's be clear, this is not the end of the software engineer, not by a long shot. It's an evolution. The job is shifting away from typing out boilerplate code and toward higher-level, more strategic work, defining intent, architecting complex systems, and making sure what's being built actually solves the business problem. These are things that require real human judgment. Which leaves us with this final, really provocative question to think about. If the AI is writing more and more of the actual code, what does the programmer of the future actually do? Well, they become the conductor of the orchestra, the architect of the blueprint, the validator of intent. Their job is to wield this incredibly powerful new tool to turn ideas into reality faster and more reliably than ever before. The real question is, are we ready for that change?